So next up, Trusted Network Connect. So Trusted Network Connect is, as the name suggests, all about network access control. And this really isn't a technology. TNC is a whole bunch of protocols, and I do mean a whole bunch, and some architectures to go with them. It is probably the most supported of the TCG's products. It's the one where like Juniper and I think Cisco and a whole bunch of various vendors do in fact say we're TNC compliant, or we support TNC. Now the thing about TNC is it's extremely flexible, to the point that saying you are TNC compliant doesn't necessarily mean everything you would like it to mean. For example, although TNC supports the use of the TPM and they say they encourage it, it's not actually required. So just because somebody says we are TNC compliant, we support TNC, doesn't mean you're getting any more assurance than you are with any existing network access control protocol, because if you're not using the TPM, you're still talking about software making claims. So this is part of the reason that adoption has been as quick as it has been. You don't have to solve any of the complicated challenges. And it does mean that they've kept their architecture very flexible and open. But it also means that if the roots of trust are optional, that just because it says it's Trusted Network Connect doesn't mean it's trusted, or should be. TNC uses some fairly standard MAC abstractions. So if you're all familiar with network access control, a lot of this will probably sound pretty generic, and that is deliberate. They are trying to do something that is easy to adopt and easy to understand in existing architectures. And the basic idea behind TNC is that a machine that wants network access presents some evidence about its identity and state, which is evaluated based on some local policy, and a decision is made as to whether or not to admit the machine. Really, this is not a very complicated idea. Of course, complicated ideas and complicated vocabulary are not really the same thing. I'm about to show you a very complicated diagram, which contains a whole lot of acronyms. This slide is only here so you can make some sense out of the bunch of acronym soup that you're about to get handed. So the two that are really critical is the access requester, which is the machine that wants network access, and the policy enforcement point, which is the gateway machine that can allow or deny access. These are the only two pieces of TNC that are actually required. Why, yes, if you're doing a network access control policy, you do in fact need a machine that wants network access and somebody that's giving it to you or not. Very hard to get any simpler than that. Among the multitude of optional components that are involved, you can have a separate policy decision point, which could be on the same machine as the policy enforcement point, but doesn't need to be, which is what actually evaluates the access request and decides whether or not to grant it. So you might have a router that's the enforcement point and then a machine in the back end that the router says, here's the data, and the decision point says yay or nay, or they could be one gateway machine. You can do fancy things involving metadata. And I'll be perfectly honest, if you ask me what's going on with the whole metadata access points and metadata clients, I'm going to pretty much nod and smile at you and say, policies can be complicated. They involve metadata potentially. This is about all I know about that, except there's a lot going on back there, and people who care a lot about access control policies and enterprise level compliance love all this metadata stuff. That's not me. There's also the concept of platform trust services, which is basically the software running on the client, the access requester, that interfaces between TNC and the TPM. So now that we've gone through acronym soup, this is why I mostly treat TNC as this pretty picture full of clouds. Because once you start getting away from pretty pictures full of clouds, TNC is a mess. It is full of little tiny protocols here. So we've got protocols for the low-level components to talk to each other. We've got protocols for the high-level components to talk to each other. We've got protocols for the high-level components to talk to the low-level components. different ones for the client and the verifier. We've got protocols for the metadata folks to talk to each other. You may have noticed this is very, very complicated. TNC is an architecture with a whole bunch of protocols for communication. So when somebody says, we support TNC, what they really mean is whichever section of the architecture their product fits into speaks these protocols. That's really what TNC support means. And each of these protocols is really a very small set of required data. Frankly, it's usually headers and footers, and a whole lot of optional report pieces, for example. So IF-M is the high-level protocol in which I, as a client, provide the state reports to the verifier. And the only thing that's really required in there is a name, and a few other minor pieces like that. And then you optionally have high-level state reports from software. You optionally have a TPM quote. It's only optionally signed. There's a whole lot of options on there. And TNC can give you some great features if you turn all of the options on, but you don't have to. So is TNC good or not, is TNC providing you any benefits or not, really depends very heavily on how you're implementing TNC. Also, not all of these protocols were necessarily designed very well to work together. This is one of the areas which drives me most batty. Because, for example, the protocols at the IF-M level all say, look here, I'm providing you with a report, but the report isn't signed. You say, why isn't the report signed? Well, they say, well, we're running over IF-T, which is itself a secured channel. But I'm not sure that they ever explicitly mention, or at least they may mention, there's hundreds of pages of documentation here. I didn't find it, but who knows? It could be in there somewhere, that says, I should check as a verifier whether the person I think I'm talking to on the secure channel is the same person whose report I think I'm reading. Very minor check, not hard to do, but when you've scattered everything over 12 protocols, making sure that you actually are connecting them in the right way is not always trivial. And in fact, we have found at least one rather significant and rather nasty flaw connecting IF-M to the vertical in its own. So zooming in a little bit, because that diagram wasn't complicated enough, if you're just looking at, ignore all the metadata stuff, and just look at the client and the decision point, now we're starting to get into this idea where I've got the TPM at the bottom. We've got a software stack, this platform trust service that sits on top of the TSS, which we're going to get to a little bit later, the trusted software stack. It's basically a software interface to the TPM. You can think of it as a driver with a slightly different interface. It's a different API to the TPM. Whether it's a simpler one or a more complicated one really depends on whether you prefer programming in C or assembler, because they're both ludicrously complicated. And then there's a Trusted Network Connect client, and there's certain integrity measurement collectors, or basically software applications that do platform measurement. One thing that is good to note about TNC that they are doing right is that you've got verifiers that are meant to correspond to collectors. So you don't necessarily have one generic verifier. You might have a verifier that verifies TPM data and a separate verifier that knows how to interpret antivirus data. And that's an idea we're going to see a lot when we're talking about attestation. So some of the TNC concepts are pretty solid. But it's tremendously complicated. I'm not going to talk too much about most of these details because, as I say, this is hundreds of pages of APIs and communications protocols. And I have not read most of them. So what I will do is give you a warning about one protocol that I have read in detail. That PTS stack that I told you binds up to IF-M, which is the protocol for providing reports. And unfortunately, the folks who designed IF-M were not TPM experts. And they designed themselves a protocol that breaks terribly if anyone else on your network is using any other attestation techniques. Which is to say, if anyone else on the network ever uses a TPM quote, PTS-IF-N breaks. Which is to say there's a man-in-the-middle attack that I will be going into in more detail later. But what this does mean about TNC is that just because it's TNC doesn't mean you can necessarily believe it, and just because TNC says they support the TPM doesn't necessarily mean you want to use that particular variation. So TNC by itself doesn't actually really give you trust. You need to care about which components they're using, which protocols they're using, which of the options are turned on. And if you do decide you want to buy a TNC product, you do need to ask a lot more questions about whether they use the TPM, and if they are using the TPM, how, the previous note about that man-in-the-middle attack.